Hello everyone, welcome to our Day 4 notes on the intermediate value theorem. It's important to know the words here, intermediate value theorem. However, when you're referencing this or writing this in a justification, you can use the abbreviation IVT. Is acceptable. AP graders will know what you're talking about. But again, intermediate just kind of means like in the middle value. So it's like a middle value theorem, intermediate value theorem. So let's take a look at the theorem, right? When we read it the first time, this is probably going to be a little confusing to you, but we'll kind of break it down step by step and go through and hopefully start to make sense of this. Just like with continuity at a point, intermediate value theorem is often something you have to justify on the test. So it's important that we can craft a really good justification. Conceptually, I don't think this is very difficult, but constructing a good justification can be definitely more challenging. So here's what we have for a definition. Why don't you go ahead and pause the video now and just copy this down, and then we'll make sense of it together. Okay, so here it says, if f is a continuous function, okay, so we know what continuous means. We know, we've been talking about continuity, it means it's connected, right? There are no holes or jumps or vertical asymptotes. On the closed interval 8b, and d is a number between f of a and f of b. All right, let's stop here and just kind of get a little sketch of what's going on. So here's a and b. And we know that the function f is continuous on the closed interval a, b. So maybe it looks something like this. So we see points there at A and B, and we know that they are connected to each other, right, in a continuous fashion. So you can sketch anything you want here between A and B, but it just has to be continuous. And you do something like this. Okay, but you could have all kinds of crazy stuff going on here, as long as you don't have any holes, right? Any removable discontinuities, any jump discontinuities, or any infinite discontinuities. Okay, so there's what we have. And it says D is a number in between, between f of A and f of B. So let's get f of A and f of B on here. Those are just our y values. So f of A is the y value where A is. It happens to be here on my picture. F of B then would be up here. And what it says is that D is in between f of A and f of B. So D is somewhere in here. It doesn't say specifically where, but it just says somewhere in between them. Okay? What the intermediate value theorem guarantees is that there is at least one number C between A and B. So somewhere in here, between A and B is C. Such that f of C equals D. So again, maybe this was D, and here's this point where we hit that. So basically, as long as we know that we have a value D in between f of A and f of B, there's got to be somewhere where C, there must be some C, somewhere in between A and B, we have to hit that value. Basically, what it guarantees is every value, as long as the function is continuous here, as long as f is continuous, we have to go through every y value in between f of A and f of B. Okay? So we have to hit every y value. Okay? You can try and avoid it, but you can't. You're going to hit it at some point in time. In fact, right, no matter how I connect this, let me just use different colors to show you different possible f values. Right, this is what I'm trying to hit, this d value. If I connect it, I can go as long as I can, but at some point in time, I have to hit that line. I might hit it right away. Okay, I could hit it somewhere. In fact, the only way that I could miss that is if I break continuity, right? I could do something like this. And that blue line there avoided hitting D, but again, I broke this rule about continuity. So as long as we're continuous, and D is between f of A and f of B, I have to go through that at some point in time. We might go through it once, twice, 3 times, 50 times, okay? But we're going to hit it somewhere in there, at least one time, okay? So let's take a look at some examples. Okay. So here's our first example. So we'll start with this, f of x equals x squared minus 5. Okay, so here's the problem. So we're given this function f of x. It says f of x equals x squared minus 5. It says, is there a value c on the interval 0 to 5, the closed interval 0 to 5, where f of c equals 4? Justify. Okay, so because we're saying justify, we cannot just simply say yes or no, or yes, it's continuous, right? We have to go through some steps. I'm going to show you the things that we need to include on here, okay? So the first thing that we want to look at is our interval, right? We're looking on the interval, the closed interval 0 to 5. So that's telling us our A and B. Okay. So then C must be between A and B somewhere. Okay. And the value D, the value that we're trying to figure out if it's intermediate or not, is 4. Okay, so the first thing I always want you to think about when you're justifying this is our function continuous? We'll take a look. F of x equals x squared minus 5. Polynomials are 100% of the time continuous, but we need to state that so the grader knows that we know that. So we'll say this. Okay. So since f of x is a polynomial, f of x is continuous everywhere. Okay? In order to use IVT, you have to state continuity. Okay? As we go on and on, sometimes that can be a little bit more difficult, but we must state continuity. Without continuity, we saw that the IVT doesn't guarantee us anything. Okay, so I've stated continuity. Now I want to show that this f of c, that 4, is is intermediate to f of a and f of b. So I have to figure out f of a and f of b. So I'm showing that f of 0 is negative 5, and f of 5 is 20. Right, so that's my f of a and f of b, but a happens to be 0, b happens to be 5. Is 4 a number that's in between negative 5 and 20? Absolutely. Right, and we just want to show that. So I'm proving that f of c here is in between f of a and f of b, right? We can do that with a compound inequality, or you could write out words. You could say 4 is between negative 5 and 20. That also would be acceptable. I think it's just quicker to write the compound inequality here. Okay? So I've proved that the function is continuous. I've proved that 4 is intermediate to negative 5 and 20. The last thing I need to do is just state that f of c must equal 4 somewhere because of the IVT. And we're done. Now notice, I never found what C was. This problem didn't ask me to do that. It just asked me, can I guarantee that there is one? And again, think about this in terms of a graph real quick. X squared minus 5, we know what that graph looks like. Right. And here's 4. Yeah, we have to go through 4 somewhere. Okay, it's not a very precise graph. Okay, but somewhere in there, I can't have a continuous function that goes from a y value of negative 5 to a y value of 20 and avoids the number 4. Okay, it's impossible. Now, for a good justification, here are the 3 things you need. Okay, we need to know you must state that f is continuous, which I did. We must show that our d value is in between f of a and f of b, which we did, and we must invoke the IVT, which we did. Okay, so when I'm checking these justifications, I'm reading them to see if they're making sense, and I'm looking for those 3 things. If you just say yes because of the IVT, you will not get any credit. So we have to be very careful with our justifications here. Okay, so there's an example with a function. Okay, I'd say the majority of the time I see this tested in the AP test, it comes in the form of a table. So go ahead and just copy this table down as I do. Okay, so here we have a table of values, right? These are all points. We see the point negative 315. We see the point 0, 10. We see the 0.32, 6, -4, 9, -10. Okay. So whenever you see a table, they're always going to have a description of that table below. Make sure you read it carefully because they're going to give you some crucial information. So here's what they might say. So they might say something like this. Above is a table of values for the continuous function h of x. Okay, so when we read that, like, yeah, obviously it's a table of h of x values. Okay, but there's a huge keyword jumping out at you. They are telling you that h is continuous. Does that mean we can use the IVT? 100% yes. Okay, without that, if I just said above is a table of values for the function h of x, if I omitted that word continuous, I can't do any IVT problems for this table because I need to know it's continuous. And with a table, they're going to have to tell you that because you can't know for sure based on a table. We only see those collection of 5 points, right? It could have a jump in it, it could have an asymptote, who knows what. Okay, can we guarantee? So here's the question. Can we guarantee there is a value c where -3 is less than c is less than 9, right? So we're looking between our x values of -3, which is on the left part of the table here, and +9, which is on the right side. Can we guarantee there's a c in there somewhere where h of c equals 0? And then again, we have to justify, okay? So again, our first step, right, when we're using the IVT to justify, okay, we have to follow those 3 things that we looked at last time. They don't necessarily have to be always in this order, but I like to keep them in that order so I don't forget one of the steps. So first off, we must state that h is continuous. Even though it says it in the problem prompt, you need to write that again in your response. If you don't, no credit. Don't forget. So the first thing I'm going to say is h of x is given as a continuous function. In my head, I'm going to make a little check mark, remembering that I stated continuity. Okay? Now I have to think about f of a and f of b. Again, my -3 here is my a. This is like my a. And this is like my b. Okay? So I need to look at my table and figure out f of a and f of b. Okay, so I see that not f, h, right? So let's take a look at those 2 values. H of -3 was 15. I get that right here. And h of 9 was -10, right here. And now I want to show that what I'm trying to find again, oh yeah, h of c equals 0. I want to prove that 0 is between negative 10 and 15. Right? So again, I want to write my compound inequality. I want to do it carefully. I'll write my littlest one first and then use all less than signs. Negative 10 is less than 0 is less than 15. Right? So I'm in my head now. I've framed this what they want as in between negative 10 and 15, right? It would not just work for 0, it could work for literally any number between negative 10 and 15. It could have been h of c equals 11, or h of z equals negative 8, or h of c equals 14. It could just be anything between negative 10 and 15 will work. There must and I could say because of IVT. Again, I'm checking that last box of referencing the intermediate value theorem, the IVT. Right? So there we see it in table form and in function form. In graph form, it's pretty easy to figure out. Okay. So again, make sure we have those three things in our justification, and make sure it makes sense when we read it. And that's it for today. We'll take a look at some of these problems next week. I'll talk to you guys later. Bye.